Welcome to Singapore Junior Physics Olympiad 2012 General Round Question 40. A charged particle moves in a circular path in the magnetic field of B equals to 0.8 Tesla. As shown in the diagram below, the particle takes 2.0 times 10 to the power negative 4 seconds to travel from A to B, and then continues to take another 1.0 times 10 to the power negative 3 seconds to go from B to A. The distance between A and B is 0.30 meter, and the charge on the particles is 3.0 times 10 to the power negative 8 coulomb. The momentum of the particle is, the options are A. 7.2 times 10 to the power negative 9 kg meter per second, B. 3.6 times 10 to the power negative 9 kg meter per second, C. 1.44 times 10 to the power negative 8 kg meter per second, D. 2.88 times 10 to the power negative 8 kg meter per second, or E. 5.76 times 10 to the power negative 8 kg meter per second. So we know that the force of a moving charged particle in a magnetic field is given by this equation here. And from this vector equation, we can see that the direction of the force is always perpendicular to the direction of the motion of the charged particle. Therefore, this force also acts as the centripetal force, which keeps the charged particle in a circular motion. So we can relate the radius of the circular motion with the parameters here from this equation as shown here. Now rearranging this equation, we can get the equation for the momentum. So the values of the charge and the magnetic field are given in the question. So to compute the momentum as requested by the question, we need to find what is the radius of the motion of the charged particle. To do that, we first need to find out the angle subtended by points A and B at the center of the circle, as given by this triangle here. So since the entire motion is carried out under uniform angular velocity, we know that the time taken to travel at each arc of a circle is just directly proportional to the angle subtended by the arc of the circle. Now using this proportionality relation, we can compute for the angle subtended by the points A and B as shown here, where this is the time taken to travel between points A and B. This is the time taken to travel the entire circle, and this is the angle subtended by the entire circle in radian, which is just 2 pi. So computing these values gives us theta equals to pi over 3. Now by studying this triangle, we can get the geometrical relations between the radius r and the angle subtended from this equation, 2r sine pi over 6, which is equals to the length between A and B, 0.3 meter. So from here we can find out that r is equals to 0.3 meter. So substituting r equals 0.3 meter as well as the value of q and b from the question into this equation, we get the final value of P equals to 7.2 times 10 to the power negative 9 kg meter per second. Therefore, the answer to this question is A. 7.2 times 10 to the power negative 9 kg meter per second.